In this video, I want to talk about the cofunctions of trigonometric functions. There's a theorem in trigonometry or in geometry that says cofunctions of complementary angles are congruent. And I want to start with us thinking about for just a minute what it means for angles to be complementary. Okay, this is a concept that would have come from most likely a geometry class. And so I'm going to pull up just a blank page and let's talk about that. Complementary angles are two angles that actually add to 90 degrees. Okay, in geometry, we talk about complementary angles. Okay, and complementary angles are two or more angles that add to 90 degrees. Or if you're thinking about it in terms of the unit circle, remember that 90 degrees is equivalent or equal to pi halves. So in example for geometry, you probably think about it more like, okay, if I tell you that an angle is, say, 32 degrees, and I ask you to find the complement, I would be willing to bet that most of you know that in order to answer that question, to find the complement, you would take 90 degrees and subtract 32 degrees and get your answer, which is 58 degrees. And so we call a 32 degree angle and a 58 degree angle complementary because 32 degrees plus the 58 degrees would add to 90. Okay, so complementary angles are two or more angles that add to 90 degrees. You can also think about it in the context of a right triangle. If we think about our right triangles that we deal with a lot within trigonometry, okay, and you know that the angle of the triangle is 90, the total of the angles in the triangle has to be 180 degrees. What we know is that angle A and angle B are complementary. And so if I know, for example, again, that angle A is, say, 27 degrees, I can determine the value for angle B by subtracting, again, 90 degrees minus the 27 degrees. And so I know that that angle is going to be 63 degrees. What you may not have connected this to is the unit circle. Okay, so let me see if I can pull up my version of the unit circle and let's take a look at that because I want you to kind of maybe hopefully see that as well. So let me see. All right, here's my unit circle. All right, so what we're saying is, if you think about this, that in terms of the unit circle, a 30 degree angle whoops, sorry about that. My pen's getting a little crazy on me. All right, my 30 degree angle and my 60 degree angle would be complementary, okay, because 30 plus 60 is 90 degrees. So a 30 degree angle and a 60 degree angle are complementary. And what the rule says that we're going to talk about here in a minute is that the cosine of 30 degrees would be the same as the sine of 60 degrees. And guys, you can see that if you look here on the graph, because look, right here, the cosine corresponds to the x-coordinate, and it's square root 3 over 2. The sine corresponds to the y-coordinate, and so you can see visually on the graph that those two angles are complementary. Okay, you can also look at, if you again look at that in terms of, we could say that the sine of 30 degrees is the same as the cosine of 60 degrees. Okay, and there are other relationships. And notice when I'm listing these two, the pairs that go together. Okay, because you have one that has co and one that doesn't. That's why they're called cofunctions. Co and then not co. And again, guys, if you'll notice and pay attention, look at the unit circle. Okay, look at the unit circle. Your sine of 30 is 1/2, and your cosine of 60 is 1/2. They're equal. Okay, so that's kind of the idea or the premise behind cofunctions. There are really three pairs of cofunctions. Again, you have a function, and then it has a co. So you have sine pairs with cosine. You have secant paired with cosecant. You have tangent paired with cotangent. So I feel like that maybe you guys are trying to overthink it a little bit in terms of identifying the cofunction. So let's see if we can take a look at a couple of quick examples here. All right, the instructions read, write the following function in terms of its cofunction. Okay, so the first one tells me cosine. So I have to stop and think. This one, in this case, you're given the co, so its partner would be the one without the co. And since this is cosine, I'm even going to write it out. This is cosine. Its partner is sine. Okay, so I know that eventually I'm going to write this particular problem in terms of sine. And what the other thing I have to remember that is that it has to be a complementary angle. So if you want to literally write it out in terms of the formula or the equation up there, you would have here in this case the cosine, whoops, skipped on me there. Sorry about that. Erase that and we'll scroll back up. Okay, you would have cosine of 18 degrees is equal to the sine of 90 degrees minus 18 degrees. And then you simply have to do the math. The cosine of 18 degrees is equal to the sine of 90 minus 18. Okay, and so 90 minus 18 is 72. So my cofunction for this problem would be the sine of 72 degrees because I have cosine and sine. Those are the two that go together. All right, looking at the next one. Initially I have cotangent. Okay, so I have cotangent. Again, I'm starting with the one that has the co. Its partner would be the one without the co, which is tangent. Okay, so we connect cotangent to tangent. Thinking about that pair, I would have, again, using the formula, I would have the cotangent of 36 degrees is equal to the tangent. Oops, I didn't abbreviate there, sorry. The tangent of 90 degrees minus the 36 degrees. Okay, and so if I simplify that, cotangent of 36 degrees is equal to the tangent of 90 minus 36, that's 54. So tangent of 54 degrees. So the cofunction for cotangent 36 is tangent of 54 degrees. You can also use cofunctions if you think about it, again, with respect to your unit circle, okay, so that you have things in terms of radians or pi. So here again, initially we have sine. So its partner needs to have the co, so we're trying to find the cosine, and again, of the complementary angle. Normally we think about it when we're doing degrees. You need to remember that 90 degrees is the same as pi halves. So again, if I'm thinking about it from a formula perspective, I would have the sine of 5 pi twelfths is equal to the cosine of pi halves minus 5 pi twelfths. And here's where it may get a little challenging for you, because in order to subtract pi halves and 5 pi twelfths, since they're fractions, you do have to have a common denominator. So I'm going to go off over here to the side for a minute, and I'm going to do this scratch work. So my common denominator for pi halves and 5 pi twelfths is going to be 12. Okay. So 2 times 6 would give me 12. So I need to multiply by 6. So I have 6 pi in the numerator. 12 times 1 would give me 12. And 1 times 5 pi is 5 pi. And if I subtract those, we end up with 1 pi 12. So in terms of, again, my formula, you would have the sine of 5 pi twelfths equals the cosine of pi twelfths. Okay, the next one we talk about secant. Okay, so if you want to think about what partners with secant, we have secant, and then you need the function that has co, so that's going to be cosecant. So again, if you want to think about it from kind of that formula perspective, you would have the secant of 3 pi eighths equals the cosecant of 90 degrees or pi halves minus 3 pi eighths. Now here again, in order to subtract those two things, you do have to have a common denominator. So you probably have to go over to the side and do some scratch work. So if I have pi halves minus 3 pi eighths, my common denominator is going to be 8. 2 times 4 is 8. 4 times pi is 4 pi. 8 times 1 is 8. Times 3 pi is minus 3 pi. So 4 pi minus 3 pi gives me positive pi eighths. So that tells me that I have the secant of 3 pi eighths is the same as the cosecant of 1 pi eighths. Okay? All right. For the next one, I want you to pause the video, okay, and see if you can figure out the answer to the cotangent of 5 pi 16ths. What's the cofunction of the cotangent of 5 pi 16ths. You should get the tangent of 3 pi 16ths. Okay, pause again and see if you can find the cofunction of the tangent of 5 pi 12ths. Pause the video again and see if you can find the value, the cofunction of tangent of 5 pi 12ths. Okay, you should have gotten the cotangent of pi 12ths.